Right, we're going to talk about kinetic energy during collisions. In the previous lesson, we talked about the conservation of momentum, and we stated that momentum is conserved in all collisions, assuming, of course, that no external forces apply. So, in a collision such as this one, where a smaller object hits a massive stationary object and then they both move off together, here momentum will be conserved. That means the momentum of this object plus the momentum of this object will be equal to the momentum of this object after the collision. And you can write a nice equation for that. I'll show you some that look like this. Momentum before equals momentum after. Now with kinetic energy, it's slightly different. There are two types of situation to consider. The first one is inelastic. The definition of an inelastic collision is simply that kinetic energy is lost. I'm waving two fingers in a kind of comma sign. It's lost because it's not really lost. It's transferred into less useful types. So it's transferred during a collision, converted into other types of energy, right? So the amount of kinetic energy that you have before is going to be much greater or greater than the amount of kinetic energy that you have after. The second type of collision is an elastic collision. Now, some of you have asked me about specific situations. Is an elastic collision when the ball bounces back, blah, blah, blah. Forget it. Don't worry about specific situations. The full definition is that kinetic energy is not lost. This means that the kinetic energy before is going to be equal to the total kinetic energy after, right? And so you have to build an equation and do a calculation to find out if it's truly elastic. There is no energy lost as sound, no energy lost as heat. The kinetic energy is conserved in the collision. Okay, so how do you know if an object or an object is involved in a interaction or a collision which is elastic or inelastic? You have to calculate the total energy before and compare it to the total energy after. So here we have two billiard balls colliding. One is traveling in a direction, right? So we'll just say it's towards the right, 2 meters per second. And this one is traveling to the left at 6 meters per second. It's 100 grams. They're both 100 grams in mass. The first thing to bear in mind is that kinetic energy is a scalar. That means we do not need to worry about the plus or minus sign. This is only for momentum, which is a vector. So, show by calculation whether the collision is elastic or inelastic. We need to work out the kinetic energy of this object using the relationship 1/2 mv squared and add it to the kinetic energy of this object using 1/2 mv squared. This will give us the total kinetic energy before the collision. Then we need to compare it to the kinetic energy after. If you read this question carefully, you will see that they give you the information about the red ball. They tell you that the red ball recoils at 5 meters per second this way, but they don't tell you what the velocity of this object is. So what I want you to do now, I want you to use conservation of momentum to find the velocity of the blue ball after the collision. Once you've found the velocity of the blue ball, work out the kinetic energy before and then compare it to the kinetic energy after. Stop the video and have a go at that. Right, as you can see, conservation of momentum enables you to work out the velocity of the blue ball. You work out the momentum before, you add the momentum of each individual ball remembering that the velocity is in the minus direction for the blue ball if you have used the plus direction for this ball, right? So you work out your velocity and you should get 1 meter per second. Then you work out the kinetic energy before the collision, the kinetic energy of the blue ball, this one, plus the kinetic energy of this one. Then you find out the kinetic energy of both of those balls together after the collision. Half mv squared of the red one, half mv squared of the blue one, and add it. What we can see here is that the arrangement had 2 joules of kinetic energy before and 1.3 joules of kinetic energy after. So it is an inelastic collision. All right, so now practice the assignment questions.